Alright, so I always like to start with making a picture of what the actual situation is. So the ball is being dropped from a height of 100 meters. And every time it bounces to 75% of its former position. So obviously not very accurate, but that's fine. And I'm going to label my bounces. Bounce 1, 2, 3, 4. And I want to set up my equation so that T1 is the term after the first bounce. So T7 will be the term after the 7th bounce. If you want to set it up differently, that's fine. Both should work well. Okay, so in my situation, I want to find the value of T7. So this is just your original equation, Tn equals AR to the power of n minus 1. My A is going to be my first term. So if this is 100, this will be my height of T1 is 75% of 100. So this is 75. Obviously not very well to scale. So A equals 75. R, since you're multiplying each height by 3/4 to get the next height, your R is 3/4 or 0.75. And your N, I want to find the value of T7, so my N is 7. Okay, plug those into your equation and you can get the answer. So T7 equals 75 times 0.75 to the power of n minus 1 is 7 minus 1, so it's to the power of 6. And you get 13.3 when you round it. Alright, your total vertical distance. So this one picture definitely helps. If we're looking at the path of the ball, and as I've labeled it, here's your first bounce, second, third, fourth, fifth, sixth bounce. And then we'll add in one more for the 7th time it hits the ground. I've labeled this as T1, T2, T3, T4, T5, and T6. These, for the T1 bounce, ball reaches a height of 75 meters. So the distance that's traveled in that full bounce from the first time hitting the ground to the second will be 2 times 75 because it needs to go up to 75 meters and then come back down again. So this distance is 2 times the value of T1. Same for T2. Whatever T2 is, has to go up to that value and then back down again. So this distance is 2 times the value of T2, 2 times T3, 2 times T4, 2 times T5, and 2 times T6. So that tells you that from the first time it hits the ground to the 7th, your total distance is going to be 2 times T1 plus T2 plus T3, so on, plus T6. Or in other words, 2 times the sum from 1 to 6. So 2 times S6. That gets you from the first bounce to the 7th. Then don't forget your very first. This distance here, being dropped from 100 meters to the ground, travels a distance of 100 meters. So this part there is 100 meters. So your total distance, I could label that as D total, equals 100 plus 2 times the sum from 1 to 6. So to solve this, first of all, I have to find out what that sum is. So I'll write down the equation. sum from 1 to 6 equals a times r to the n minus 1 divided by r minus 1. So I know from the previous part of the question that a equals 75, r equals 0.75. My n is 6, because I want to find the sum of the first 6 complete bounces. So when you plug that in, you get sum from 1 to 6 equals 75 times 0.75 to the 6th minus 1 divided by 0.75 minus 1. If you're doing this in your calculator in one step, don't forget to put brackets around the calculator, otherwise you'll get a wrong answer. So when you do that, you get 246.6 something 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 meters. Great. So now that you know S6, you can plug that into the formula that you found for the total distance. And you'll get total distance equals 100 plus 2 times, you found that S6 was 246.6. Store the whole thing in your calculator because that's not your final answer. And you get an answer of 593.2 something 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 meters. Should be rounded to the nearest tenth of a meter, so 593 meters is your total distance. That's when it just touches the ground for the 7th time. Okay, how many times does the ball need to bounce to travel approximately 675 meters in vertical distance? Okay, so we could figure out how many times does the ball need to hit the ground for this to travel 675 meters in vertical distance, because we've already got a formula for that. The total distance when the ball hits the ground is 100 plus 2 times the sum. So if the ball hit the ground for the 7th time, we needed the 6th, sum from 1 to 6, term 1 to 6. If the ball hit the ground for the 8th time, we need the sum from 1 to 7. So the sum, the number of the sum, is 1 less than the number of times that the ball hits the ground. So if the ball hits the ground n times, you want the sum from 1 to n minus 1. Okay. Then all we have to do is solve this equation for n. So you know that your total distance is 675, so put that in. You know that the formula for S of n minus 1 equals a times r to the n minus 1 divided by r minus 1. And you know your a value and your r value. So a is 75 still, r is 0.75. Okay, so now you can write out the equation long form. So you'll get 675, your d total, equals 100 plus 2 times our a is 75 times r 0.75 to the n minus 1 divided by 0.75 minus 1. Alright, so you're trying to solve for n. So get the group that has n in it by itself. I'll subtract 100 from both sides. So 575 equals 2 times 75 times 0.75 to the power of n minus 1 divided by negative 0.25. Okay, so this group I need to get by itself, so I'll divide by 2 and divide by 75, and then I'll multiply by negative 0.25. And you end up with negative 287.5 divided by 300 equals 0.75 to the power of n minus 1 minus 1. Now I'm going to add 1 to both sides, or in other words, add 300 over 300. So I end up with 12.5 divided by 300 equals 0.75 to the power of n minus 1. Okay. It's difficult to solve this without your calculator right now, so go to your calculator. You can use the intersect feature. Use 12.5 over 300 as one of the equations, 0.75 to the power of n minus 1 as the other. Alright, so your first equation is going to be 12.5 divided by 300. Second equation is your 0.75 to the power of, remember that n minus 1 has to be a single exponent, so put brackets around the exponent, to the power of bracket x minus 1 bracket. Your 12.5 to the power of 300, so it's less than 1, so to see it clearly, great, once you see the intersection, you need to calculate intersect, enter, enter, enter. So your intersection happens when x equals 12.047 something. So almost exactly 12. So if you go back to this means that your value of n equals 12. So remember, n was the number of times that the ball hit the ground. So exactly when the ball hits the ground for the 12th time, it will have traveled approximately 675 meters. Another way to say this, just like when you saw when the ball hit the ground for the 7th time, you could say that it had traveled 6 complete bounces. So if the ball hits the 12th time, you could say 11 complete bounces. Either way is fine, just make it very clear what your n refers to. So this is 675 meters traveled after ball hits the ground for the 12th time. And it'll be just barely after that.